All right. Well, good morning. My name's Jonathan Howell. I'm with a senior project engineer here at CAVS Extension, and I'm excited today to be hosting this webinar for everybody. The goal of this webinar is so we can give you a what to expect at MyTex Mississippi, but we're also going to cover some topics about AMRs. These are some of the same kind of topics that you would see at our MyTex event, and I'm so grateful to have the two presenters that we have with us here this morning to be able to get this kicked off with this preview event for us. After we get through with this what to expect, I'll give you some instructions on the webinar and introduce those guys, and we'll get it going for the day. So what to expect at MyTex Mississippi. So in the past, you may have heard this called our Innovation Conference, and we've rebranded it now to the Manufacturing Innovation and Technology Exchange. This year, it's being sponsored by the companies that you can see across that banner. And it's being hosted by the people at the bottom there. And we've had those hosts for the past 10 years or so as we've done this event. And we're very grateful for everything they do, as well as our sponsors and the support that they provide for us to be able to provide this event for the public. Um, there we go. The event is comprised of 3 days. The first day is a golf tournament. So on Monday, April 13th, we invite you to join us for the MAMA 2026 Spring Golf Tournament. This is at the Refuge Golf Course in Flowood. This is a great opportunity to connect with industry peers while supporting scholarships for Mississippi future automotive and manufacturing workforce, as MAMA has, over the past 20 years, been able to give $430,000 towards that program for future automotive manufacturing workforce through different scholarships and programs that we have. It's a beautiful golf course. The weather should be great. So if you like to play golf, make sure you get signed up for that through our website to be a part of that and that networking event there. The next day, on Tuesday, the 14th, we'll have our tech exchange. And this is going to take place at the Nissan Training Center over there across the street from our building here in Canton, Mississippi, just on the north end of the Nissan campus over there. So you can join manufacturing leaders from across the region to discuss different things. We'll have panels composed of industry professionals, subject matter experts, and workforce development representatives. And they'll all be sharing practical insights on automation, robotics, artificial intelligence, digital twin, advanced materials, and workforce strategies. This is designed for manufacturers preparing for what's next. But please note the space is limited, so make sure that you register. We do need you to register for this event. Unlike the next event that we'll go through that's just open, this one does require registration. Space is limited for this venue, and we want to give priority to manufacturers. So if you register from one of our Mississippi manufacturing companies, we will give you priority to be able to attend this event. We're really looking forward to this. We had a similar event last year that would have been labeled Smart Tech Mississippi, and this is the same style event. We have a lot of good panel discussions prepared and breakout sessions as well. And we're really looking forward to the discussions and outcomes of this and the different questions that it may answer for companies as they're looking to implement advanced automation within their companies. And then on the third day, on the 15th, which is Wednesday, from 8 a.m. to 5 p.m., we have our MyTex Mississippi Innovation Conference. This is going to happen at the Nissan North America plant in Canton. At the main lobby entrance is where you'll enter. If you're familiar with that plant, there's a red awning kind of in the middle of the plant. That's where you'll come in through, and you'll park in that parking lot right in front of it. This is an annual event that we've done, like I said before. Before it was labeled as the Innovation Conference. And that's what we're calling it now, but it's part of MyTex Mississippi. And this brings together manufacturers from across the region to explore cutting-edge technologies, improving quality and productivity. We have over 30 exhibitors this year, and the list is growing. And you can see some of those exhibitors listed there in our word cloud on the slide. But they're going to have displays related to automation, robotics, and digital manufacturing, and the conference is free and open to the public. So this makes it a must-attend event for engineers and leaders and manufacturing professionals. This is a great opportunity for our Mississippi manufacturing companies to be able to attend an event like this at a no cost, minus the travel that may be needed to get here. But we hope that we're centrally located so most people can make the day trip and not have to spend a lot of money on travel to be able to attend this event and see all these different displays and hands-on demonstrations from these companies that we have here. This is a great event. We have it every year. We look forward to it. We're excited about it this year, and we hope that if you aren't planning to attend, that you can mark your calendar and plan to be with us for those days. If you need more information, you can go to our website. I have it listed here, but also you can use the Scan Me QR code there to go ahead and get all the information that you would need. And I'm going to show it on my screen here so you can see what it looks like. So when you go to this website, we have a countdown going at the top, and then we go to the bottom here. Here's the 3 days, and you'll just click on those days to learn more. So if you want to register for that technology exchange, like I said, be sure to do that. You'll need to click here and get yourself registered. There's no registration for the Innovation Conference, but you can click there for more information and the full list of exhibitors and different things like that. And as always, if you have any questions about this, feel free to reach out to our CAVZ team. We'll be glad to help you work through any questions that you might have. All right. So now we're going to lead into our actual webinar that we have going on today, which is our tech preview with the AMR fleet management and Cobot integration. And I'm so excited to have our 2 presenters that we have with us today. We have a presenter from KUKA and ACS, and they have some really good topics to cover with us. So I'm going to go ahead and introduce those guys now in the beginning here as we go through. So we have Stephen Cruey, who is with KUKA. He's an account manager in AMRs, and he is going to be talking about AMR and fleet management. He has a lot of experience with integrating AMRs within systems and complex systems and using fleet management to be able to control those AMRs in plant. He has a great presentation today, and I'm excited for you guys to see it. And then after him, we'll have Kel Harbor. He's a VP of Product Management at Advanced Control Solutions. He's got over 15 years of experience integrating automation into processes. He's a very knowledgeable guy. He's a problem solver, always wants to help out. And today he's going to be talking about our AMR and Cobot integration. Both these guys have prepared great presentations. I've seen them. I'm very excited for you guys to see them today. And I hope that it answers a lot of questions that you may have about AMRs, but also it may spark new questions that you have, and we can have some discussions to help answer those questions. And leading into that, if we could utilize the chat today to ask our questions. And the reason for that is we may run out of time, or there may be a question that these guys can't answer right off the top of their head. But if you put it in the chat, we're able to follow up with it via email after this webinar, and that's the plan. So any questions that don't get answered, we will make sure our presenters get those, and they'll be able to follow up with those questions to you via email. All right, so without any further ado, I'm going to pass this over to Stephen and let him get started with his presentation for the day.
Thank you, Jonathan. Nice to meet everybody virtually, and excited to partner again with Jonathan and the MyTex team as we have the past couple of years. So let me share my screen here. So as I mentioned, I'm Stephen Cruey with the KUKA AMR team. We've had a team here in North America for about 3 years. We are a global company, and as much experience as I have with AMRs, I wouldn't be anything without my organization. We're a $4 billion company, a global footprint, and have made the first 6-axis robot with a partnership in Volkswagen going back in the 70s. So I'm based in Tampa, Florida. Went to Delta State University, and mainly focused on the Southeast, but more strategic accounts and automotive focus as well. So as I mentioned, what KUKA brings to the table. Just want to give you a little introduction on who I am, what I cover. As I mentioned, we're a 127-year-old company. We actually started moving autonomously with mobile platforms going back to 2009. So quite a bit of history, and you see the different iterations of products, not only physically, but software driven regarding the fleet manager, which I'll talk about soon. But quite a bit of an experience, right? So a majority of the industry, took on AMRs or brought AMRs to market in 2019 and 2020. And, we've been doing, moving autonomously since 2013, and actually moving up to about 100 tons. So I say all that to, give the credit to KUKA, but just let you know that, we are a global presence, a global company with a very mature product. And as I mentioned, we got our start with 6-axis robots, and AMRs have just complemented that as well. So we have 6-axis robots that are doing everything from brain surgery to moving cars, right? So there's one for every application. And I always like to start with the introduction because I think just industry wide, we've seen AGVs for 30, 40 years. I was watching How It's Made not too long ago, and it was pretty wild to see an AGV, going back 40, 50 years, so they've got us up to this point, but that technology has evolved to where we can go fully autonomous. So think about an AGV as a more of like a train. It's on a track, whether it's a magnetic strip or you need optical guidance. I've seen, AGVs that had a series of grids with QR codes to read in the ceiling every, 4 or 5 feet. So really on day one with an AGV, you create a maintenance task to have to integrate or maintain that solution. So it becomes a very rigid, though it is mobile, it's more fixed like a conveyor. With an AMR, what we'll be talking about today, we're talking about autonomous mobile robots. So the same technology you see that the automated cars, Tesla uses and other Waymo and other autonomous vehicles use is the same technology that's on our AMRs. With that, it gives you a lot of flexibility, a lot more efficiency, and the ability to adapt as you grow or change your facility or workflows. And the integration becomes a lot easier. So what are things and tools to consider, when you do that integration? And I'll focus more on the software side, but, really in every day-to-day conversation I have when I'm introducing, my portfolio, I think we can get narrow-minded and look and say, hey, well, I have a forklift, I just replaced with an AMR, right? Well, no, this is a true edge technology that needs to be integrated, and we should treat it as such. So when we look at it, we have that mechanical piece, right? So how are we going to mechanically adapt my physical AMR to my workflow? The other part is the software piece. Do we need to? KUKA has an on-premise server, so we try and eliminate any of those cloud-based issues, firewall issues, access issues for IT, but who do we need to get involved, right? Do we need to get IT involved? Is there any documentation that we need to figure out? Software, I also kind of include IT as a whole. Do I have my Wi-Fi network set up? Have I done a site survey for Wi-Fi at ground level where the AMRs are operating, not at chest level? And then, how do I envision that AMR working with my operators or working with autonomously with my current workflow or robotic cell or what have you, right? So a lot of things to consider. And if we stay narrow-minded on just the AMR piece, when we go to deploy one or start to scale these out, we'll miss a lot of items here that would kind of railroad our application moving forward. So when we talk about the mechanical piece, so KUKA has a standard built-in lift top, so it will go underneath and lift up. So it's an integrated lift module. So do we need to consider, how we're going to pick up that pallet or payload or mechanical rack, right? Do I need to outfit it with a conveyor? KUKA has power on board, so we can, power a roller-driven conveyor. So we think about the ultimate flexibility. A 500-foot of conveyor is always going to be 500 feet of conveyor. With an AMR, you basically have you can do your 40 by 48 pallet movement with, a roller top here. Do I need to add RFID? Do I need to add any IoT devices like lights, or I've even seen like those ATV whip lights for visibility. We have power on board where you can enable those things. So when we think about the mechanical side, it's how am I going to stage that product to be able to utilize this AMR, go underneath, pick it up, or have a fixed top module where I can lift up and adapt to my flow there, my product there. So what is an AMR fleet manager, right? So I think that's what we really want to define here. is just really discussed, like, what is a fleet manager? What do I need to consider when doing that integration? Because the mechanical part is mechanical, and the AMR physical part is fairly easy. You know, you take a remote control, you drive the AMR around like an RC car, you teach it your map, you teach it your locations, and then what, right? So really, you know, an AMR fleet manager is is a centralized software that acts as the orchestrator to an AMR fleet. So whether it's one AMR or 100 AMRs, and becomes that single source of integration to a workflow, process, or solution. So let's think about it like an air traffic controller. If when I have integrated AGVs, I had to hard code every route and every AGV and handshake. So if I had 100 AGVs, I had to integrate 100, you know, different units. With the AMR, you have a central location like an air traffic controller where I integrate my my workflow or my adaptation to my process. Similar to an air traffic controller, if all planes were taking off and landing and they were reporting back to air traffic controller saying, "Hey, I'm taking off now," or "I'm landing now," it wouldn't be very scalable, right? We'd have a lot of chaos. But that air traffic controller is helping navigating those landings, helping, you know, those takeoffs, helping understand the weather, you know, receiving outside information so the pilots can just focus on doing what they do best. So think about it, you know, the fleet manager is going to enable those AMRs and that fleet to do what it does best. You know, that's navigating the environment, receiving missions, moving, you know, at optimal efficiency, handling obstacle avoidance, doing traffic control, traffic management, you know, managing the charging strategy, right? And then it's just receiving all this information from all the, you know, other edge technologies. Any questions so far? Perfect. All
Not
right, so
seeing any in the
let's
chat, Stephen, so keep going. But if anybody does, please remember to utilize that chat there for your questions.
perfect. Yeah, feel free to stop me at any time. So let's take a look at what direct integration to fleet looks like. So as I mentioned, the KUKA fleet manager, so whether I have one AMR or 200 AMRs, we operate on one fleet manager, right? So that's an on-premise fleet manager. We have all these different models here. You could have one of each or 20 of each. So hopefully you can follow this here. It's trying to make it as easy as possible. So we have our server that's on premise, right? So we need to have our fleet manager. So KUKA's fleet manager is a Linux-based server. We deploy that server on the main system here. Maybe I'm taking a you know, SAP, like a warehouse management system. That would need to be hosted on this server. And then we need to have all of our devices that we need to do handshakes with. So essentially, maybe the end of a line of a conveyor, or a barcode read, or a simple push button, or a photo eye. Maybe the AMR goes, or a pallet shows up, it triggers that photo eye to trigger a mission for an AMR to come pick it up. We've done things as simple as trash management. So there was just a height sensor, and once the trash got to a certain height, it triggered a mission for an AMR to come, you know, pick up that trash bin. So as long as all my devices are hosted on the same server, you can see here the AMR will kind of go from the ground up. So all the AMRs, we've mapped out our facility. We have good Wi-Fi coverage. That's communicating. We point that IP to the fleet manager that's hosted on the server. All my other devices are hosted on the server, and you know, now basically, if I got a call from, you know, this push button that, hey, I have an operator's done with a workflow, or done, you know, loading a pallet, they push a button on an HMI or what have you, and call an AMR. So that mission goes down to the fleet manager. The fleet manager will send a mission, you know, to that AMR to go pick it up. Or I could have more of your upper level systems driving the solution. So I have a product that's going through a process. Automotive is always easy to reference. So maybe I'm in the trim and assembly process, and I know that I need to drop this certain kit of solution, kit of items to be assembled, and we'll say SAP for lack of better reference. So a warehouse management system will send that order down. KUKA Fleet Manager has an API. We've already set up, that communication language between these systems. That order is dropped down and it commissions an AMR to go pick it up. Or you could do both, right? So our Fleet Manager is more of an open source, meet you at the communication style that you need. One thing to consider with the direct fleet integration is the more logic you start to add, the more and/or logic you start to add, you'll want to look at the next step, which we'll talk about in a second, adding more of a middleware. If you have simple missions, maybe you're doing that crawl, walk, run approach where you just have one deployed, one or two AMRs deployed, and I'm doing simple missions back and forth. This is where you could consider that direct integration to the Fleet Manager. It's nothing too crazy. This can be all self-contained, but the last thing you want to do is bog down a Fleet Manager with all the controls that it's really not designed for, right? That's what these type of solutions are for. So the most common applications or deployments that I see here in North America, we'll talk a bit about some VDA 5050 here shortly, but the majority, if not all, applications that I see at scale have this middleware software, right? So this is more of that data orchestrator. So this sits in between the Fleet Manager or other edge technologies. So think about this middleware as that broker that before, where I was directly going to the Fleet Manager, this middle software can receive all this data, broker that information down to the Fleet Manager. I've seen things advanced as communicating to data analytics, employee-driven like metric systems, IoT devices for alerting, end-of-line triggers, and then warehouse management systems. So you think about all those different things that you have to integrate into a workflow, or they're operating within a facility. Having this middleware is really decouples a layer of complexity because you don't have to do as much logic, right? You set up the communication strategy between each one of these devices, and it's set up to receive it. Any questions? Perfect. So then lastly, I think a lot of people have, we talk about VDA 5050. So, and a lot of people are kind of like, what is that? Well, essentially it's, designed to make a centralized fleet manager for, any AMR or AGV that has VDA 5050 compliance can be deployed on. So in this case, if KUKA has VDA 5050 capabilities, we have a native integration to NACE and Synals and some other European solutions. Some of the automotive companies I work with do require it, but I haven't seen really very many deployments yet in the automotive industry. It has been required for me to win some of the applications that I have, but it hasn't been fully deployed. I have seen it more over in Europe. But VDA 5050 was kind of created to be that centralized fleet manager. So you would remove, in this case, you would remove my fleet manager, and this middleware would be that VDA 5050 solution. So it really helps with traffic management, or if I have multiple AGV systems or AMR systems, it becomes that one centralized fleet or that master control system. So it was the German Association of Automotive Industry created it, along with the Material Handling and Interlogistics Association. So they developed a VDA 5050 standard to create that universal communication interface between AMRs and AGVs. So really the goal is to create that true interoperability. So all my devices that are VDA 50 compliant goes to one central fleet manager. But what I'm still seeing in the industry, something to consider is, okay, so I still have this centralized fleet manager. I still might need that middleware software to communicate to other systems. It just depends on the level of integration or version that you get, where all the devices can be hosted on the fleet there. So this is what the data looks like going, the data looks like going back and forth. So really, essentially, it's an MQTT broker that's receiving JSON messages via MQTT. So orders flow from the fleet manager to the AMR. It's checking the state and then give you that visualization within that fleet manager. So if you don't have any questions, I'll move on to some applications. Covered quite a bit there. Perfect. So now to the fun part. Let's take a look at some applications here. So this is an automotive application. A lot of what I'm working on, whether tier one suppliers or OEM automotive applications. You can see here where our AMR is, utilizing the built-in lift here. You can see the levels of integration that you need. So you have the fleet manager that's helping provide this navigation portion. It's doing the interaction to trigger, muting light curtains, receiving the mission to move and where the location needs to go. And then here you can see the utilized lift top and alerting lights and LEDs on board as well. So cool thing here is we can handle overhanging payloads. A lot of the automotive applications I have are bigger racks, and you can still maintain a safety compliance. This application required 3 KMP 1500 AMRs, 6 new racks or these docking stands that it picked up from. There was a little bit of floor prep required, targets on the floor or on the racks to localize off of. And what they were actually able to remove is 4 sets of wheels on the racks, and basically remove these cross braces there as well. So sometimes less is more with the AMR. I have a lot of applications where I'm pulling out a lot of these roller beds or inbound conveyance for the AMR to make it AMR friendly. And let's see. In this show here, we'll jump over to this application here. So this is a video, but this is a very complex application. So this is mixed case picking. So when we think about the ultimate flow of data or complexity of integration, this is it. So I have, essentially a warehouse management system that is managing all these SKUs and all these orders from North Shore's facilities. You have a combination of voice picking and barcode readers. You have your pack out, and then you have rates to hit. So what we're doing here is providing the map, providing our location within that map so it can be exposed to the software, and basically we're receiving orders and a location to go to, so the operator can continuously pick and fulfill this order here. This is something that a lot of folks have been trying to figure out, and I think really the power in doing this is that centralized fleet manager and being able to expose location. So to reiterate here, operators receiving, he has his voice pick solution. So he's telling them, hey, go to location A or B, pick SKU number 1, 2, 3, or 4, this quantity. He's scanning it with his Ring barcode scanner, and then that voice is also directing him like where to go and what to pick, and he's filling that order there. And then we're moving along, and then we'll take it to pack out.
Steven, that audio is not coming through. If you maybe want to just click that closed captioning button on the bottom right, so at least it shows text.
Thank you. So that's your mixed case picking there. Here's another very unique application, and I think you'll start to see more of this. So robotic loading and unloading with to an AMR. So we have this 6-axis location, 6-axis cage here. It's picking and placing the materials for this AMR to go, pick up in this, I guess, little horseshoe there. So the robotic cell receives the orders. The AMR works in tandem as well to know where to go, where to load, and it starts to fulfill this pallet here. So you think about the orchestration of location with the AMR, SKUs, right? So you're managing which items to pick and building out that pallet for that order to go out. But if you think about what this is doing, as opposed to a forklift operator having to go in and stage these and sort these out, or manually loading and unloading these, this is becoming more of that shuttle system to make those quick runs back and forth. We're starting to see a lot more of these concepts, especially when we think about trying to eliminate some of the non-value added tasks, and somebody pushing a cart 5 miles a day, or manually picking up and placing multiple materials all day long. How do we repurpose that operator to do something more beneficial? And then we have our auto docking charger. I think something to really consider. The unique part here is, this is a simple 3-prong 110 volt versus AGVs that have more of a fleet lead acid battery. So you're looking at sometimes 1 or 2 batteries that are $20,000-$25,000 versus a $6,000 lithium ion battery, and then a very modular charger. So I'm sure we've all seen a battery farm in the back of a facility. So when you think about just the sheer power and energy savings alone, it's something to consider. and you don't have to manage your charging strategy. It's going to automatically dock. And that's all I have. No questions.
Yeah, if anybody's got any questions, be sure to get those in the chat for us. We'd be glad to answer them. And while we're doing that, I got a couple, Stephen, just
Yeah.
based off some challenges I've had. So, you showed earlier the Wi-Fi requirement. So I'm guessing, it is required to have Wi-Fi in your facility to be able to utilize the fleet manager, which I guess makes sense because you can't have these guys attached to a cord driving around.
Yeah.
But I have a question about that. What happens if one of your units loses their Wi-Fi connectivity? What happens? Does it stop, or is it able to continue and gain it back? Or
Yeah, so the AMR, like our fleet manager is designed to complete that mission and get to a safe stopping point. So if that mission is, I pick up the mission is triggered, this AMR needs to go pick up this pallet, take it from location A to location B, and drop it, and then that's the complete of the mission that's set up in the system. It's going to fulfill that mission, then stop. So it's not going to stop just because it loses Wi-Fi en route.
okay, so it actually complete the mission and then get to a safe spot to go kind of into a holding pattern. Does it have to be manually recovered after that, or if it gains Wi-Fi back, will it auto recover?
It will auto recover and pick up, where you're left off. Something to consider is, because I've seen this a lot of times. It's if you're staging, I wouldn't stage more than 5 to 10 missions in a fleet manager, depend on how, basically what I mean by that is you have SAP or warehouse management system sending triggers, and they need to be within, a certain order. The more you put on the fleet manager, the more you have to, if you lose Wi-Fi or lose signal, you have to kind of backtrack on, right? It will pick up and follow orders, pick up where it's left off. But if you need to handle an exception, you don't want to dump 1,000 orders or missions into the fleet manager, right? So just something to consider. And that's really more of order fulfillment that has issues with that. But it's really with any device that you use. But it's also designed if a fire alarm went off, we can set it up to where it goes to a safe zone. And if it loses Wi-Fi on the way, it's going to make sure it gets to that safe zone. So.
Yeah, so the mapping is handled locally on the robot, so it's able to still continue to know where it's at based off of its mapping that's locally to the robot itself. That's really interesting about the fire alarm thing. That's not something we all think about, but you're right. You probably do want to try to save your assets and equipment if you can, right? Have them evacuate along with the people. Another question I have that I've dealt with before too is, you have a AMR running a mission, and maybe somebody comes in and they block its path with a forklift, and it's not able to come devise a new path. Are you able to remotely correct that on the AMR, or does that require somebody to go out and manually connect to the AMR with a controller and move it, or can they handle that remotely? Maybe like you'd mentioned, fleet manager, air traffic controller. In my mind, I think you would have to have somebody kind of managing and watching that fleet manager, right, to kind of see where everything's moving around. And I've had an instance in a facility where a forklift driver got in a dance with an AMR, and they just kept going back and forth. Would an operator be able to remotely come in and basically tell that AMR, hey, park here and wait, let that forklift get by, and then continue on?
Yeah, so you can set up a very, I guess, dynamic, strategy. So that really goes into obstacle avoidance or what to do when I get in that deadlock. So say, for instance, I'm in a deadlock and I don't have my obstacle avoidance on. And what that is basically I see an obstacle, I'm going to navigate around it within a safety tolerance that I know the payload, the widths that I have to operate in. If I can navigate around that, it's going to try to. Or you can put it in a static obstacle avoidance, I guess, zone where if I see an obstacle, I'm just going to stop and wait for that to clear. You can have like a timer. So basically, if I'm at a deadlock for 2 minutes, I'm going to trigger an alarm to, text the maintenance personnel to take a look, right? Or go on the map and click on the fleet manager for it to go a different route. A lot of times obstacle avoidance is mainly used in like long runs where maybe a box or something could drop down off of other devices or other forklifts, and I can navigate around it. But a majority of the time, we're setting up preferred zones, right? So a lot of it is coaching that interaction with the personnel on the floor too. So forklift traffic stays over here, AMR stay over there. Is what we try and do. Not always the case, but that's really what the dashboard is for, and that ability to communicate out what's happening. So whether it's triggering or alerting on the fleet manager that you have an AMR that's stopped, or an IoT device that sends out a strobe light or something, right? So you can manually go drive it around, but you shouldn't have to.
That's good to know.
If you're at, let's take worst case scenario. Forklift goes in the aisleway, goes sideways, and is completely dead. The forklift is, and the AMR is just sitting there like, what do I do? You can put it in a manual. Basically, go up to it, turn it to manual, manually back it out, and kind of send it a different direction and put it back to autonomous, and it'll pick up where it left off. There's not a lot of localization. I know what you're talking about. I don't want to talk about other brands. I don't talk about other solutions, but it's not where you have to go put it up to a localization marker, let you know where it is. One thing we do extremely well is stay localized. We have an NVIDIA chip built into each AMR, and there's a lot of enhancements and constant referencing of its map and the environment and what's fixed and what changes. So you'll start to see that accelerate more to maybe even visual perception engines where I can see a physical forklift and know that that's an output and do a series of actions. So
good deal. Does anybody else have any questions? All right. Well, if not, we really appreciate Stephen and your time today to give this presentation. Very good and informative. If it does generate questions after this for anybody who's attending, please feel free to reach out to us. We'll connect you with Stephen. He'd be glad to answer your questions. They have a full team of guys that are really looking to help solve problems for people. And to lead into that, they're going to be at our main MyTex event. They're a diamond sponsor for it. They're going to have a booth set up. I know Stephen's going to have probably an AMR with him and some other things to show. So if you're coming to that event, plan to come and come by and see Stephen and be glad to talk to you in person and show you some more of this in person and more of the details that are involved. And then also for the technology exchange portion, one of his colleagues, Drew Sheminsky, is going to be doing a presentation, a technical session, and it's going to be on building towards an AI-enabled factory. So they're going to be talking about how KUKA is looking to and working towards integrating AI into their products and how that looks towards the future and the impact that it could have on production in your facility. So we're looking forward to that presentation. Hopefully everybody can make it for that and be able to see that. Remember to register for that event. We do have limited space in that venue, and we're giving priority to manufacturers. So thank you, Stephen. We really appreciate it. It was great. So what we're going to do now is we're going to take a 10-minute break for everybody, okay? We're going to take a 10-minute break before our next presentation for Cale. So it's right at 9:50. We'll come back at 10 o'clock. And get started. So get up and stretch, go fill up your coffee mug if you need to, get you some water, whatever you need to do, and we'll be back in 10 minutes. Thank y'all. All right. It's right at 10 o'clock. We just got back from our break. Everybody, I hope, had a chance to get up and stretch, get a cup of coffee, fill up your water bottle, whatever you need. We appreciate Stephen giving us the first presentation there on fleet management with AMRs. Looking forward to see what Cale has for us on this next presentation about AMR and Cobot integration. So at this time, Cale, I'm going to pass it off to you, man.
All right. Thank you so much, Jonathan. Mighty fine good morning to everybody. Glad to be here this morning with you and a chance to get to talk to you a little bit about some of the work we've done. My name is Cale Harbor. I am part of the Applied Automation Group. We are, just saw my screen is not showing available. Bear with me 1 second. Technical difficulties, isn't it fun? So I'm part of the Applied Automation Group. ACS is one of the 6 automation distributors that make up this group. We are based out of Marietta, Georgia, and cover 8 states in the Southeast. So we've been expanding very nice here lately, and I'm glad to get a chance to talk to everyone here this morning. Specifically, what we're going to be going into is mobile Cobot integration, actually interfacing a standard 6-axis collaborative robot arm onto a mobile platform, an AMR platform, to be able to accomplish new things in a manufacturing environment we haven't been able to do before. So that being said, before we get into it, I just kind of wanted to hit a reminder of what are some of the benefits of automation? Why do we care about automation? What is it that automation gives us? And some of these things are going to be a repeat. The first thing that everybody typically thinks of is labor savings. If you automate a process, you free up that human labor to be able to do something else. Repeatability. You have automation set up. You're going to set up that automation to be able to do the same thing every time. Same process, same assembly, same force to be able to press something together, the same surface finish. It's set up to be able to produce or to perform or service the same process repeatedly, over and over again, the same way, to the same standard. Expanding the production time. Automation typically doesn't have to have a lunch break. It doesn't have to get its PPE put on. It can start work and keep working. So being able to expand that production time through what would normally be a lunch period or a break, or even set up that piece of automation, run a batch of parts after everyone goes home, which leads to the lights out manufacturing aspect of it. We do have a customer. They have a series of machines that we're tending. They set it up with a batch of parts and go home at night. And when they come in the morning, the batch of parts are done, and they've achieved an extra 6 hours production on 6 machines without having to put any extra staff on board. So that ability to expand your production time and be able to run that lights out when no one's there is a real benefit that comes from being able to automate a process. But because we have that repeatability that I mentioned earlier, it also enables us to reduce the scrap rather than having an inconsistency that a non-automated system might bring into it. We're doing that same thing every time. We can reduce that scrap. We can reduce the rework. We can reduce the material that may not be able to meet quality standards, and therefore we get more product through in a shorter time with less effort. But one of the huge important things that we get into that gets overlooked is this reallocation of the human assets. And we've seen this time and time again. When we can deploy automation, specifically, we've seen it more with the robotics than with other things, that ability to reallocate that human asset to something that brings more value and more return to your manufacturing environment is something that typically, when that can be done, the ROI, the payback, the benefits far outweigh what the labor savings are. That ability to add to the capacity. And we're going to be talking about a real life example of this here in a moment. That's part of the unexpected benefits of automation, the things that happen that you don't really think of or expect. It's not something that's typically predicted on a spreadsheet or an ROI calculation, but improving that worker retention, the morale, by being able to redeploy that human asset to something that not only brings more value to the customer or to the employee, but also to the company itself. One of those examples that we did, this happens to be a collaborative 6-axis arm made by Universal Robots. This is an application at a life test lab. So with this one, that person's job, 40 hours a week, was to raise the blind, lower the blind, open and close. And every 30 cycles, 50 cycles, they had to record, does it feel the same? Is it getting looser? Is it getting tighter? So that they're giving their human perception to how this particular blind is feeling over that test. And they have to do that until the blind fails. So this is usually about a 6-week test period that they're doing. So this 6-week period, that person's job, 40 hours a week, 8 hours a day, is to just perform this motion. Raise it, lower it, open, close, and every 50 cycles or so record, is it changing or not? Well, that human perspective on whether it's changing is not very empirical. And needless to say, they had a very high turnover rate in this job position. One of the benefits that we had when we deployed this arm in with this customer was that the employee they had working at this station to actually perform this task had a high school degree, did not attend college, was not a degreed engineer, but we worked with them and trained them on how to use this technology. What they were able to do is that employee who showed up for work, was reliable, someone they wanted to keep, they didn't want to lose, got us promotion to be the robot technician. They got a pay raise. They were able to retain that employee, which means they didn't have to go through rehire and training. Then, with this technology in place, it could run 24 hours a day, through lunches, overnight, and because of the force sensors in it, they were able to get real-world data on the actual amount of torque it was taking to raise and lower this blind that they were able to do more specific analysis with. But one of the other things that happened is they could now complete an entire test in 3 or 4 days. They were able to get 6 to 8 units tested in the same period of time that it took one previous. They then added a second robot to this, and that one person was able to be the robot technicians for both cells to be able to set it up from one test to the next. Keeping that employee, keeping that person that showed up when they were supposed to, being able to achieve the cycle test that much faster far outweighed all the other benefits that they got out of this. But in addition, they also got better data coming out of it. Another scenario that we did, this was a different customer. This is involving a mobile robot platform. So we're working with mobile industrial robotics. This is another area that we had where, and I just realized my text did not change this, I apologize. But in this particular case, they had a team of people on every shift, 3 shifts a day, anywhere between 8 to 12, that were walking 8 to 10 miles a day just to deliver material line side. We were able to work with them and add an IoT appliance, that middleware between their MES warehouse software system and the mobile robot fleet, to work with the lines so that when they called for material, we knew where the parts were staged and able to engage those carts and then deliver the parts to the production line. In this particular case, we freed up between 8 to 12 people per shift, 3 shifts a day, to perform higher level tasks, things that human beings could do better than what just pushing a cart around would be. But then be able to deploy it in a safe environment to be able to deal with obstacles, move around barriers, be able to notice where people are so that it's able to get around safely and still accomplish its mission to keep the parts fed to the production line. So here we've got Scooby's friends, Ike and Tina. Right now, the fleets at this facility, we're running over 80 AMRs here to be able to keep up with the production lines quite successfully. So with these 2 technologies, these are 2 great case stories about how we were really able to add not only the value that it brought to the production line, but those unexpected values of reallocating that human asset to do something higher level, to be able to do something that brought additional value. But what happens when you combine those technologies together into a mobile Cobot platform? So in this particular scenario, this is that 6-axis collaborative arm on top of an AMR, which is also collaborative, able to sense the things around it and be safe in its environment around people, and be able to put them together to be able to solve a task or a mission or a set of needs that's on the manufacturing floor. Now, what exactly is a mobile cobot? A mobile cobot is combined of 3 different pieces. One is going to be the actual collaborative arm, in this case, a universal robot, a near AMR, mobile industrial robot, but we combine it together with a platform that ties the two together. And when I mention the word we tie them together, it's more than just the mechanical connections. In addition to that, the software is also combined so that all of the commands for the 6-axis arm, all of the commands for the mobile platform is in one common, easy to use interface. We're still able to talk to the fleet software. We're still able to talk to the middleware to give us access into the SAP system, ERP, warehouse management system. But it makes it simpler and easier to deploy by having just the one interface to be able to work with and combine these together. So what can you do with a mobile cobot? Again, they can run 24 hours a day. They can run through no lunch breaks, no putting on of PPE, no PPE purchases for it. It's able to just be able to run. Once it's programmed, you don't have to do additional training. It's going to provide that repeatability to do the same process every time. Now, we can make the mission with the right decisions, the right statements to be able to choose. If this is not ready, then do that type scenarios, but it's going to do it repeatedly, reliably, and predictably. With this, we're able to communicate with all of the existing equipment on the floor, either directly or through a middleware setup. And we can provide those logs to be able to say, how many missions did we complete? How many parts did we deliver? In the case of this particular scenario that we have here, we have a particular cobot with shelves on it, picking up bins of parts to be able to take to the warehouse to get refilled or to bring parts to the line and put it on a particular workstation. This environment can also, because of the flexibility, if we're not dealing with a set of shelves, we're putting things into the rack of the machine to be able to keep it fed. We're able to do that as well. But we're able to work in the environment because of the mapping and the localization that we have. Most environments require just minimal modifications for us to be able to work in. And we'll get into some of those examples here in just a second. But this is also a technology that can be gradually phased in. If there's a potential to be able to do 10 of these in an area, it's not an all or nothing. We can start with one, be able to get it in place, get the employees on the floor familiar with the technology of seeing it run around, be able to work out the details of the communications, and then expand as you go. So as your workflows change, you're able to easily adapt that. And again, through the fleet interface, be able to make that change and have it go to all robots simultaneously. So if a workflow or work path does change, we're able to easily adapt to it and be less sensitive to those changes. Now, just as a quick reminder, what is the difference in an AMR? I'm using that word, not everybody's familiar with it, but an AMR is an autonomous mobile robot. In the last 30, 40 years, we've seen AGV technology. AGV is typically following a magnetic rail, a wire embedded in the floor, could be QR codes in the ceiling, but it provides something that it has to interact with to follow a path. And if something blocks that path, it's not able to go around it. It has to follow its line. AMR, an autonomous mobile robot, is able to sense the world around it through its sensors. And it's trackless, meaning if something is in its way, like you saw in my video with Scooby, when the young lady stepped out into the aisleway, was able to see, was able to spot that there's an obstacle there, and be able to make decisions on how to safely go around it, provided there is a safe way around it. But when we take this technology, this AMR technology, and we add it to a 6-axis arm to turn it into a mobile cobot, there's some additional things we have to consider, and they're fairly basic, they're straightforward. When we add that 6-axis arm and we're going to combine it with this platform, what's the reach we need to achieve? Can we reach from the lowest point to the highest point that we need to be able to achieve the mission, to be able to achieve the task at hand? What is the payload? we have to be able to have not only a 6-axis arm capable of lifting the load, but an AMR of also sufficient status to be able to transport that load from one spot to the next. The other thing is cycle time. As the robot is moving, it's keeping safety first above everything else. Now, obviously, we can work with the speeds, we can optimize it out, but as obstacles come in the way, as pedestrians get in front of it, or a box were to fall off and get left in the aisle that we have to navigate around, all that takes time. So we have to know what the cycle time for an application is to make sure, can we achieve what we need to, or do we need more than one robot to be able to achieve it? So those are some of the basic things that we need to consider for the arm. For the AMR, things such as the aisle width. Is the aisleway wide enough to allow the robot to move down it? Or if we need multiple robots, can two pass each other to get from the warehouse to the workstation, for example? How are we going to start the mission? We're going to talk about this in another slide in a moment, but think about how you want the operator to interface with this system. Is it a push button? Is it an automatic call from a PLC? Is it going to be a custom dashboard? And we'll get into that momentarily. The fleet management, being able to keep up with multiple AMRs within a facility and be able to manage them for emergency egress, charging stations, map sharing, mission allocation. All of that still has to happen, and we have to consider how we want that to behave as we're deploying. The traffic flow. This is one I think sometimes can get overlooked. When we began working with this technology almost 10 years ago, we had customers misunderstand about what the collaborative means. Collaborative on the AMR and the ARM itself, we are capable, provided the risk assessment is done and we meet the application itself meets the requirements, of working next to human beings without a problem. Human beings can walk into the area, the robot will see them. However, the more people in the area and the more often the robot has to stop to calculate a safe way to go around them, the longer the time it's going to take. So thinking about traffic flow, we don't have to be in a traffic-free area, but the higher the traffic is with people, forklifts, tuggers, or other vehicles within the area, the more crowded it is, the more time it's going to take to safely find a path through that. When the traffic is lower, we're going to be able to get through the area with fewer interruptions. So being able to hit your tap time of how long it takes to complete a mission, the traffic flow does enter into that. We do need good localization. Now we're working off of sensors that are sensing the environment around it. I've got another slide that will talk about that in more detail, but we have to make sure that we maintain position of where we're at. So that's something that has to be looked at. And then of course, a stable Wi-Fi. Especially if we're running more than one robot with fleet, we have to communicate with PLCs, warehouse management systems, or other systems within the facility. We do need that stable Wi-Fi to be able to work. So these are just some of the things to consider as you're looking at deploying a mobile cobot for the first time. That being said, let's look at an example of what this might look like. So this is one of the smaller platforms. On the end of the arm, there is a 3D camera. That 3D camera is looking at a chessboard grid that is attached to, in this case, the tote itself. And why that's there is when that tote gets placed on the shelf, it does not have to be placed precisely with dial pins or precision data or things like that. The camera is able to take a picture of that grid and be able to adapt for an angle difference within the tote itself or the position of where it's at and adjust the coordinates of the robot accordingly. So in this particular case, the robot's come up. It's looked to the shelves for the empty bins. It has retrieved the empty bins next to this workstation, and it's now going to take them back to the inventory area to be refilled and then bring them back to the area. So this is one where if we have that human being at that particular workstation and they're doing the assembly, we can keep the parts fed to them without having someone push a cart over every time or just walk back and forth from that warehouse area, just not really adding value to what's being made. Now, mobile cobots, though, can come in multiple sizes. The previous video showed the one on the left, which was the smaller platform. The larger platforms, we can go much higher payloads and much longer reaches with the 6-axis arms we're able to put on top of it. So in this particular scenario, we've got larger totes that we're dealing with. Again, able to pick them up, be able to grab either the empties or the full, load them onto the platform, and then be able to carry them to where they need to go, whether it's back to the warehouse to get refilled or it's the production line to bring those filled units to the line for the operators to be able to work with it. Now, this particular scenario is showing a machine tending setup. So here we're delivering bins to an in-feed conveyor. These are the empties. So we're feeding those empties into it to be able to get filled at the machine itself. And then we're going to pick up the full ones coming out the outfeed conveyor and carry them to the warehouse. Pick up another set of empties and we'll come right back and keep it full. So in this particular scenario, we're having the unit be able to service multiple machining centers, be able to palletize the load, and then keep the line fed with parts. As those parts get full, it's able to bring it back out to the line, place it where it needs to go to be able to keep production moving. Another scenario, we're interfacing with gravity feed shelving in this particular case. So being able to deliver those totes, again, whether full or empty, to that gravity feed to keep that operator station up and running, complete with parts or complete with empties to be able to put finished parts into and be able to keep it tending. So again, that larger platform, that larger arm, we're able to reach farther, carry our heavy loads, but still maintain the safety standards that we need in order to deal with obstacles, people within the environment, or things maybe even getting left in the aisleway to be able to get around safely and accomplish the mission. One thing to keep in mind is that within this platform, the fleet manager is able to manage all of the different size robots, whether it's the small ones, the large ones, dedicated AMRs without a mobile cobot on top, or even the pallet jack that we have to be able to move full pallets on point-to-point moves from floor to floor. All of that is managed by the same fleet environment and can share the same resources. Now, how the robot actually works is we're using a series of sensors to be able to scan the environment around us. You see here in the example of this map, when we begin working with the robot, we put it in record mode. As we drive around the facility, we're bringing that data in and we're setting the initial map so that everything that you see in black here happens to be permanent fixtures. The walls, the machine stands, the palletizer, the machining center, the workstation, whatever is in your environment that is stationary and permanent. The lines that you see in red are the live data coming in from the sensors. That has to overlay the map of the permanent items to at least 30% so that the robot maintains and knows where it is. You'll notice in the middle of the floor, there's red lines there that are not laid over black permanent fixtures. Those are movable obstacles, either workstations, carts, people that are in the environment that the sensors are able to see, be able to account for. And then the purple haze that you see around it as the robot is moving is the safety zone, the minimum distance we have to stay away from that obstacle to make sure that the person or the cart or whatever it is safe, as well as the robot being maintained safe as well. And we have to be able to navigate between not only the obstacles, but those safety zones around it. Things to think about as you are setting up a mobile cobot platform is, what's your route plan? Is there a particular route plan that you want the robots to stay in? Is it going to be looped around the facility? Is there only one aisle where robots have to go in and come out? If so, is that aisleway clear and free of debris? Is it wide enough to either allow a single robot to go down, or if we need more than one robot to keep up with the tack time, Is it wide enough to allow two to pass each other so that we can maintain the production rate and still be able to deliver parts effectively for it? What's the floor maintenance look like? Does it have potholes? We have seen some floors that had some very significant damage to it. We're able to deal with small chips, but potholes would definitely be a problem. The other thing is, does the floor have a high gloss finish? Very high gloss epoxy coated floors that are extremely reflective. Those can cause issues with the sensor sometimes, and we do need to know that going into it. Identify where your pickup and drop off locations are. Where do we need to pick up the parts from? Where do we need to drop them off at so that we make sure that we're able to hit those targets effectively, have room for more than one robot to get around, and be able to navigate the way that we need to. And again, as I mentioned earlier, what other traffic's in the area? Is this a high traffic area for fork trucks? Is it a high traffic pedestrian area? Do we need to account for maybe additional signals for either traffic lights? Do we need to be able to play a sound, flash lights, get someone's attention? Or is the environment rather a low traffic area and there's not much there, so that we really don't have much that we have to interact with? The other thing that's important, is there a champion? Is there someone at the facility that is going to be the champion to understand the technology and how to interface with it? Should the robot be blocked in for a period of time, it can't get out, has no way to get out? Is there someone able to manually move the robot to a new position, get the obstacle out of the way? If we run into a scenario where we are running lights out delivering parts, but somebody happens to block the aisle on both ends and the robot can't get back to the charger, is there someone there who can help it recover and be able to understand what's going on and how to prevent that from happening? So having that champion on site, someone at your facility that's able to work with the technology, understand how to interface with it, and deal with those small interruptions that happen in life and keep things moving effectively is very critical to be able to have a high-performing system. And some of the things that we look out when we come on site to be able to do a deployment, one of those things is a Wi-Fi assessment. This happens to be a live map of a customer's location that we worked with. We're able to use the mobile robot itself and pull diagnostics from it. So we created a map, we ran the unit around the facility, we downloaded the logs, and we took a look at it in the analyzer to be able to determine their Wi-Fi strength. And in this particular case, it was a good thing that we did. Green is good, red is bad. So you can see here, they definitely had to invest a little bit in their Wi-Fi to be able to support the fleet of robots that they were hoping to put in. And I will say they did get that done, and we have a very successful install running there now. But being able to understand what's going on within the facility for that Wi-Fi strength and what's going on at the location to be able to make sure that we're covered is critical to understand before we get started. Another site file that we did, this one, I've got two different maps coming from the analytics. One is that localization map. How well is our sensor data matching up to the map so that we maintain where we're at? Again, green being good, very strong localization in this case. We knew where we were at, no issues there, very stable, very reliable. Their Wi-Fi, as we got started, we were able to quickly identify that for the majority of the facility, they had adequate Wi-Fi, one area stronger than the middle, but they did have a weak area in one spot. So in this case, they added one additional wireless access point working with their IT group, and they were able to overcome that and have a functional platform afterwards. But again, we were able to define this up front before we actually got started in the major part of the deployment to keep things moving quickly and efficiently without an interruption. So we were able to identify this beforehand. Now, one of the things that was mentioned in the previous session has to do in this type scenario. What happens, though, if something occurs within the map or something occurs within the environment to get in the way of the AMR as it's trying to complete the motion, as it's trying to complete the mission? So in this scenario, you see here, there's a good 15, 20 feet of floor space around this forklift that the AMR would be able to go around. It physically would fit without a problem. But in this particular case, the robot's sitting there not moving. And again, this is where having that champion on site comes in very handy, because in order to understand what's going on, you have to look at the world the way the AMR is looking at it. So if we take a closer look at the map itself, now we can see what's going on. Again, that red data from the live sensors that you see in the middle of the screen, that's the fork truck. It is parked in an unusual spot. It's not supposed to be there. The purple haze around it being the safety zone. And if you look towards the bottom center, you'll see the arrows. This is a zone that was set up known as a one-way zone, meaning it only allows one-way traffic going, in this case, from left to right. There's not enough room between the safety zone around the fork truck and the one-way zone that we've declared. And just like in the real world, you're not allowed to drive the wrong way up a one-way street. So in this particular case, there was not a safe path for the robot to complete its mission. So it stopped. It's continuing to try to get around it. And then it sent an email notification out to be able to say, I'm in trouble. I need someone to come look at me. In this case, the champion who was on site at the facility was able to look at the map, and now they can make a decision. Do they enact signage or training for the fork truck drivers not to park there? Or do we need to look at changing the one-way zone to give it more room to get around it if that's something that they need to do? Now, changing the one-way zone might affect other things within the mission. Having it set up where the fork truck can't park there could also have other effects. But now we know exactly what we need to address and what decision needs to be made in order to optimize this map and this installation to be able to achieve its efficiency. Now, as we look at deploying a mobile cobot into a facility, one of the things that does have to be thought about are the controls. How are you going to interact with the robots to be able to call a mission, interact with the operators, etc.? One way we could do that is custom dashboard. Custom dashboard set up on the fleet with a series of buttons available to say, pick up, drop off, deliver to warehouse. In other words, at that station where that operator is, at that piece of equipment, what are the missions that they would need access to? Might be just one button, might be two or three. But in this case, anything with a web browser can be able to access this custom dashboard on the fleet and be able to enter the missions in the queue to be able to execute it. So it could be something that simple. Could be like the middle picture. Do we need a push button? Do we need an I/O access point, either via wired Ethernet or wireless Ethernet, to be able to have that operator hit that button to be able to call the robot to complete the mission, or to be able, if it's just, hey, bring me parts, be able to hit that, have the mobile cobot come over, drop off the full bins, pick up the empty bins, and carry them back to be refilled. Could be that simple push button. But if we get into automated calls from the PLC, then we need to think about if that piece of software that we're working with might be something that has API calls built into it, such as Ignition or such as SAP. Those calls can be set up and made directly from those pieces of software. If it's going to be from a PLC, typically they don't have the API calls that we need, and we need that middleware software that would use a programming environment such as what I show here. This happens to be Node-RED, to be able to issue the calls and interact to say, hey, I got a signal from the PLC. I need to call this mission to the fleet to be able to get assigned to a robot to deliver. So understanding the controls plan, understanding how your operator needs to interface with it. Is it a manual button? Is it going to be automated? If it is automated, what do we need to communicate with to determine, do we need an additional piece of middleware or not? So understanding that up front helps us lay out the control structure, and it helps us simplify the deployment of this. Now, I mentioned several things to be able to help with the deployment of this technology in the field. One of the other pieces of information we have available that I would recommend to you is a book written by Samuel Bouchard. He is the CEO of Robotique. They are a strong provider of solutions to mobile cobots, to universal robots for end-of-arm tooling and solutions. He has written a book called Lean Robotics. This is available various sources. You should be able to find it online without a problem. It's available in both print and audiobook format. But what this book does is it goes through the process of how to address and step by step walk you through deploying an automated work cell, the questions that you need to have answered, things that you need to think about, things that you need to consider, how to get a champion set up to be able to help drive that solution or drive the success of that automation project. Sam's done a nice job with this, so I would, if you're looking at a new deployment, you're looking at a new setup for automation, I'd highly recommend getting this book. It is centered around 6-axis robots, but it applies to all automation projects in my opinion. So I would highly recommend checking it out. Now, as Jonathan mentioned, upcoming, there is going to be the event coming up at or later in April. We will have a booth there. So we will have this technology on site to be able to show to you and be able to discuss. Hope to see you come by and we can answer any questions for you in person. Again, I'm with ACS, but we are part of the Applied Automation Group. Through the group itself and our sister companies, we can actually help out with any facility throughout the US and Mexico. So we have a great deal of resources at our disposal to be able to help you in your next automation project. So with that, that's what I've got and be able to answer any questions you might have.
Yeah, if anybody's got any questions, please feel free to put those in the chat so we can get those answered for you. We have time now to be able to take some as they come in, if you guys have some for Cale to answer. We'll give it a minute, see if anybody has any. I got someone typing one in now, so. Anybody else, please feel free to put those in there. And I know in our area, Cale, we're seeing more of a, getting a lot of questions about this technology. Are you guys starting to see more requests from companies in industry asking about mobile cobots and how to integrate them and the challenges do you see?
Well, we sure are. And we've got multiple, between the 6-axis arms and the mobile platform, we've got about 1,400 assets deployed within the Southeast running right now. And we're seeing the growth of the mobile cobots definitely increasing. And we're seeing a variety of applications. The ones I showed in the video, more or less delivering totes and parts to a workstation. But imagine this being a blow-fed screwdriver system and being able to drive up to a larger structure. RV, aircraft wing, something where you've got to go through multiple points. Having that vision system to have it drive up, lock in on the point, and drive those screws over a larger facility is something that's really gotten attention. We have another customer we're working with. They have to ultrasonically weld large pieces of fabric. And these pieces of fabric are 90 feet long, and they have to tack weld them. Putting the ultrasonic welding on the mobile cobot to be able to drive down that 90-foot long piece of fabric and be able to do the spot welding before it goes to the sewing department to get sewn together. Or we also are running into applications where we're putting cameras on the end of the robots. So if you've got, we have a manufacturer of large earth moving equipment. They just need to make sure all the brackets welded onto. They're not looking in their application, they're not looking dimensionally. They're just looking for, are the 16 brackets supposed to be welded there before it goes to the paint shop? and being able to drive around that larger piece of equipment or that larger item and be able to take pictures of those to make sure that everything's in place and just give a go, no go before it moves to paint. Because if it gets painted without the brackets, it's got to go to a rework area. The paint's got to get ground off. It's got to be welded. Then it's got to go back and be touched up. And it adds a lot of time to it. So that's something we're able to avoid.
Yeah, so we got a question that just came in, Kale. This is from Vinicius Regalo, and he's asking, what is the maximum payload that a mobile Cobot is able to handle?
So within the mobile Cobot family we work with, we've got two base sizes of AMRs. The smallest one is a 250 kg capacity AMR, and the highest payload 6-axis arm we can put on top of that is 16 kilograms. So that means we can pick up a tote that weighs 16 kilograms, place it on the AMR up to a 250-pound total capacity for the mobile robot to handle. In the larger platform that I showed in the video, that particular one, we can outfit it with up to a 30-kilogram collaborative robot arm. So any individual item could be up to 30 kilograms with a maximum capacity on the mobile robot of 1,350 kilograms. So basically, we can pick up 50-pound loads and place them on top until we hit, 2,800 pounds.
Yeah, I got a follow-up question for that. Does the payload in this platform with a Cobot, because it's mounted to a mobile robot, does it affect the reach of the robot? Because I'm guessing, you are limited on the payload. Like, could you hold 16-kilogram payload at the fully extended state, or does the robot have to operate kind of within a smaller reach because of any tip over risks?
No, the platforms are set up so that maximum on the small one at 16 kilograms at full reach. You're not,
okay.
Don't have to derate the 6-axis arm or derate its reach for the load. It is set up with the stability to maintain, not run into risk of tip over even at full reach. Now, obviously, though, with the robot bolted to the center axis of the robot, the distance from the center of the robot to the edge, would affect the overall reach, but that would be no different than if the robot was mounted to a column or another table. You would still have that distance between the center to the edge.
Yeah. That's good to know, because that's something I've thought about before, is how the reach was affected. So it's good to know that they are considered within that design to be able to still allow you to get that reach on the robot. But like you said, you still have to consider it is where it's mounted on the robot and how the mobile robot is able to approach the area that you're working with and take in consideration that. Again, that's what I really liked about your presentation, talking about really planning it out, right? Making sure that you have all the pieces put together to know that this is the right solution for what you need, and it can work and be successful there. All right. Do we have any more questions from anybody else that's joined us? All right. I'm not seeing anybody type any questions. So thank you, Kale, so much. We really appreciate you taking your time today to share this with us. It was really good, very informative. If anybody has any questions that may come up after this that you think about later on today, please feel free to reach out to us. We're going to send out an email here later today with our contact information for our presenters and for myself as well here at Cavs Extension. So that way you can funnel any questions back to us and we can point you in the right direction. And like Kel said, they're going to be at the event as well. So remember, that event is happening in April, coming up in a couple weeks. First day is the 13th, which is the golf tournament. The 14th is that technology exchange, and there will be more presentations and discussions similar to what we talked about today. So if you really enjoyed today's discussion and learned a lot, I really encourage you to sign up and register for that event. Space is limited, but we are giving priority to our manufacturers. There's a whole list of technical breakout sessions we're going to have and panel discussions. A lot of it is centered around the same type of information that we're seeing here today, and we'll expand on that. So be sure to register for that. And then on the last day there, we'll be at the main plant and coming through the main lobby. And we'll have all these vendors, ACS, KUKA, and all the other ones we listed earlier. We'll have their booths set up with their products. They'll be there, be able to give you hands-on demonstrations in-depth conversations, answer any questions you might have, be able to get that contact information for follow-ups at your facility if needed. So again, I really appreciate our presenters for the presentations that you gave and the time you put into it, Stephen and Kale. I really appreciate it. I appreciate everybody who was able to join virtually today for this. I know 2 hours of your day can be hard to give up, but I hope it was worth it. And I want to also give a shout out to my team in the background that's been helping out, Travis and Chase here at Cavs Extension. They've been a great help with this event. I couldn't do it without them. So thank you guys so much for being the guys behind the curtain, making everything happen like it's supposed to. And also, as Travis has put in the chat, we will post this video. We recorded the session so you can share it, or if you came in late and missed the front half, there's the link there. We'll email that out in our email later as well. And if that's all we have, I'll hang out for a few minutes. And if you have a question, feel free to put it in the chat or reach out to us. And if not, we'll give you back about 14 minutes of your day and hope you'll have a good rest of the day. Thank y'all.
Thank you, everybody. Have a great day.